question is about time-of-flight mass spectroscopy, but it involves a lot of maths, so I thought it'd be useful to make a video. A sample of copper was analysed and found to contain two isotopes, copper-63 and copper-65. All the ions were accelerated to have 1 times 10 to the minus 16 joules of kinetic energy. Having travelled through a flight tube of length 0.8 meters, the copper-63 ions took 1.29 times 10 to the minus 5 seconds. So far we've been given a kinetic energy, a length, and a time. Now the question poses, how long would 65 copper ions of mass 1.079 times 10 to the minus 25 kilograms take to travel along the same flight tube? Further information provided in this part involves the mass of the copper-65 ions. We are asked to find how long. That means we are finding a time. We need to think about how this unknown we've been asked to calculate is related to some of the knowns that we were given in the question. Formulas that involve time and distance include distance equals speed times time, an equation of motion. Furthermore, we know that kinetic energy is equal to half mv squared, where v is the speed. So we could equally write speed as v in this equation. Looking quickly at the question, we see that we know a distance. We do not know a speed. We do not know the time. The time is the thing we want to find out. In our other equation, we know the kinetic energy. We know the mass. We do not know the speed. Once we work out the speed, we can put it into this equation to finally find the time. Before we can find things out, we need to learn to rearrange equations. We want to make v, speed, the subject of this equation. This can be done by putting it onto the left-hand side. First, bring the 2 up to join the KE. Something that is divided on the left-hand side must be multiplied on the right-hand side. It's vice versa. Thus, the mass, when moving over to the right-hand side, is divided. Finally, we take the square root of this whole thing and sub in our numbers. It's helpful to keep in the units all the way through just to make sure you stay in SI units. Now we know the speed of our copper-65 ions. Finding the time taken is easy using the distance equals speed times time formula. Distance given in the question as 0.8, we just worked out the speed to be 43,053 meters per second. That leads us to find time. We must rearrange this equation. Distance will be on the top. Time equals distance over speed. 0.8 meters over meters per second. The meters will cancel. Per second on the bottom of the equation means seconds on the top. The answers in the question are given to 4 significant figures. We should too quote our answer to 4 significant figures. This means we should write the answer as 1.858
times 10 to the minus 5 seconds.
Is this plausible? This is of the same order of magnitude as the time that the Cu ions took. Therefore, we can be pretty confident that this is the answer.